Hello friends, I welcome you in lecture number 39 on graph theory. In this lecture we are going to discuss that how we can construct or draw a binary tree if we are given its pre-order and in-order traversals. In earlier lecture we have discussed that if we are given a tree, then how to find out its pre-order, in-order and post-order traversals. And in this lecture we are going in reverse direction, that how to construct a binary tree from its pre-order and in-order traversals, or how to construct a binary tree if we are given its post-order and in-order traversal. So either we are given pre-order and in-order traversals, or we are given post-order and in-order traversals, and using them we can construct or draw a unique binary tree. So before understanding this method, we just recall that what was the pre-order, in-order and post-order traversal algorithms which we have discussed in earlier lecture, that is in lecture number 38. So in pre-order, if you recall, we can first process the root, then we are processing the left subtree and then right subtree. So I am shortly write root, left and right. In order, we are first considering left subtree, then root and then right subtree, and for post order we are considering left subtree first, then right subtree, and then we process the root. So in pre-order, root is at the beginning, in post-order root is at last, and in order root is in between left and right subtree. So with this in mind, we try to understand first that how to construct a binary tree from pre-order and in-order traversals, and then we will discuss how to construct a binary tree from post-order and in-order traversals. So in both the cases we must be given in-order traversal. So here I have taken one example of binary tree traversal. I have given this information that a binary tree has 9 nodes, and draw the diagram of that binary tree denoted by capital T if the pre-order and in-order traversals of that binary tree yield the following sequences of nodes. That is, we are given pre-order and in-order traversals of some binary tree, and using these two traversals we have to construct that binary tree. So now we know that if we are given in-order traversal, then we know that in in-order traversal root is in the middle, that is left root and right, and in pre-order root is at the beginning, then we consider left subtree and right subtree. So from pre-order we can determine that what is the root of our binary tree. So we know that in pre-order traversal first node is always root, so G is the root of binary tree which we are interested to construct. And in in-order traversal root is in between left and right subtree. From pre-order we find that G is the root of required binary tree. So here we can see that G is at this position in in-order traversal, and in in-order traversal the left side of root is nothing but left subtree in the binary tree, and right side of root is nothing but right subtree of the binary tree. So from this we have the idea that G is the root of required binary tree, and left subtree of G will be having these 4 vertices, and right subtree will be having these 4 vertices. So first we consider the position of root. we write G here, and then for left and right subtree we are considering these edges. Now here roughly first I am writing this sequence of nodes for left subtree, and these are the nodes for right subtree. Now to process further, I have to determine that what is the left child of this root G and what is the right child of this root G. Now in this sequence we have these nodes Q, B, C and A. So we will check in pre-order that out of these 4 vertices which nodes appear first in the pre-order. If we go in this direction, then we will decide that out of these 4 nodes which node is coming first in the sequence of pre-order. So nodes are Q, B, C and A. So this is Q, this is B, this is C and this is A. So we can see that B comes first in the pre-order traversal. So this B will be considered as left child of this root G, and the part which is to the left side of B will be in the left subtree of B, and these 2 vertices will be in the right subtree of B. So now I will eliminate these 2, and this is our left child of G. So here I am now writing capital B. Now here I have only one vertex, so there is no left subtree to the left of Q, and here I have 2 vertices. So again in pre-order sequence I will check that which nodes appear first, either C or A. So I check in pre-order, here I have A and here I have C. So A appears first in pre-order, therefore we will consider right child of B as A, and here C is to the left side of A, therefore I will put C as a left child of A, and from this I will delete A. And now I have only one vertex here, so I stop here. Now same process we have to follow for this PEDR. So again we check that out of these 4 vertices which vertex comes first in the sequence of pre-order, PEDR. So let me find these 4 nodes first. This is P, E, D and R. So if we go in this direction, then P appears first in the pre-order, therefore P will become our root of G, that is right child of G, and this is to the right side of P. So here I will consider EDR at this position, and I will eliminate this EDR, and here I will write P as a right child of G, and this right subtree of P will consist of these 3 nodes. So again we check in pre-order that which vertex comes first, either E, D or R. So let me come to the position of E, D and R. Here I have E, D and R. So D comes first, therefore D will be the root here, and we will consider to the left of D we have E, so I am writing E to the left of D, and R is to the right of D, so I am writing R here, and this I will simplify as capital D. So this is the required binary tree whose pre-order and in-order traversals are given. You can see this. Let me minimize this. So this is our required binary tree. So in this way we can easily construct this binary tree if we are given its pre-order and in-order traversals. Similarly, we can construct a binary tree if we are given its in-order and post-order traversals. So now here I have given post order and in order traversal of a binary tree, and I have to draw the unique binary tree, and this question was asked in GTU Winter 2022 exam. Now whenever I am given post order, I know that in post order first we have left subtree, then right subtree, and then root. So root appears last in the post order, therefore A is the root. And in order we have left subtree, root, and then right subtree. So we can find out this root A in order. So here we have root A. So from post order we find out position of root. It is at the last position in post order. So we determine that what is the root of required binary tree using post order, and then we search that node or that root in order. So here I find out this node A in order. So this sequence of vertices will construct a left subtree of this root A, and these three vertices will form a right subtree of this root A. And in pre-order we are searching in this direction from left to right, but in post order we will search from right to left. That we have to remember the difference. Now first I will start with this vertex A. So let me write capital A here. A is the node or root of required binary tree. To the left we have this D, C, E, B and F, and to the right we have H, G and I. Now I will search in post order that out of these four vertices which vertex appear first if I go from right to left in post order. So first I will find out these vertices D, C, E, B and F. In post order first I will search that what are the positions of these vertices, and then I traverse from right to left and I find that B appears first. So here I will put B as a left child of A, and we can see that to the left of B we have this DCE. So that I will write to the left of B, and here I have this F, and here I will write B only. So let me write properly. This is node B. Now same thing I will do for this D, C and E. I will first search D, C and E in the post order. Here I have D, C and E. Then I will check from right to left and I will find that C appears first. So C will be the root here, and to the left of C we have D. So we write D here. To the right of C we have E. So we write E here, and here we consider C as the node or root of this binary tree. Now we come at this position H, G and I. So again I find out positions of H, G and I in post order, and we find that G comes first in post order, therefore G becomes root here, and to the left of G we have H, and to the right of G we have I, and this position is for vertex G. And now we can see that here I have only one node, here also one node, F, H, I. So this is the required binary tree for given post order and in order traversal. And if you remember, we have discussed shortcut method of finding pre-order, in order and post order traversals in lecture number 38. So if you want to cross verify this binary tree, you can use that shortcut method and you can check whether your binary tree generates this post order, in order and pre-order which are given in the questions. For example, suppose we check for this. So if I want to write down this in order, pre-order and post order traversals for this tree, then first I will consider this type of lines. This is for pre-order, this is for in order, this one is for in order, this is for post order. Pre-order, in order, post order, pre-order, in order, post order, pre-in post, pre-in post, pre-in and post, and pre-in post. So this is just for understanding that how we can verify our answer. Otherwise, after drawing the binary tree, we have answered this question. Now I am considering a closed curve which will traverse all the nodes. So I start with A, and here I will be writing for pre-order, in order and post order traversals. So whenever that curve will touch this line to the left of vertex, we will write that vertex in pre-order. Whenever curve will touch this line below the vertex, we will write that vertex in order, and whenever our curve touches this line, then we will write corresponding vertex in post order. So let's start with this root A. So here this curve touches this line and that corresponds to pre-order. So we write A in pre-order, similarly B in pre-order, then C in pre-order. For D I have to write, so D is also in pre-order and we traverse in this direction. So this is in order and this is for post order. Then we go in this direction and we touch this line. So C is in order. Then we come here. So E is in pre-order. Then we come here. It is for in order and E is for post order, and we continue in this way. This is for post order and this is for in order. Then this is for pre-order, this is for in order, so I write F here also. This is for post order, so I write F here, and first I have to go in this direction. So B is in post order, then this is for vertex A. So A is in order, then this is for G in pre-order, then we are coming near to H. So this is again for pre-order. Then we consider in order, that is small h here, then H in post order, G in order, I in pre-order, I in order, and I in post order, and we continue in this way. G in post order, and finally A in post order, because we are touching this line. So A in post order. So now we can check whether our in order and post order given matches with this or not. In order is DCEB, so we can see DCEB, then FA, HGI. So this is our correct binary tree. We can check for post order also. Here I have DECF, so DECF, and then BHIGA, BHIG, and I forgot to write down A. Okay, this will touch the post order line of A, so I have to write A. So whatever binary tree we have constructed using post order and in order traversal, we can verify using this shortcut method of traversing binary tree to verify our answer. Otherwise you don't have to do this again. You just use Postorder and Inorder traversals to construct your binary tree. So this is all about this session. In this session we have discussed that how to construct a binary tree if we are given Inorder and Preorder, and how to construct binary tree if we are given Inorder and Postorder traversals of a required binary tree. So I stop here. We will continue with this type of lectures on our channel. Thanks.